Hello everyone and welcome to a webinar on intelligent solution for conceptual PNIDs, plant asset management and maintenance. Today we are going to look around a solution which is intelligent and smart for creating conceptual PNIDs to engineering PNIDs up to maintenance PNIDs. So before we get started, let us see about our company. Itin Factory is a wholly owned subsidiary of Nilsoft Group, which develops process industry solutions from last 20 years. Based on object-oriented technology, its solutions work on an integrated workflow processes and comes with built-in intelligence, integration, and customization flexibility. It creates a cohesive working environment and supplements your existing investments, keeping the total cost of ownership low. Little bit about the technology. Our solutions are based on object-oriented technology with a single database. It comes with built-in PDM as well. Its modular architecture provides real integration between various disciplines like process, piping, mechanical, electrical structures, etc. Anything and everything you do in CADISON is object-based. So you have objects and object classes with the data and attributes behind it. Each object also has relationship with associative or child objects. For example, a pump will have a relationship with motor and instruments and so on. So this technology gives tremendous advantage of reusability. And based on this philosophy, it is offering three solutions. One is Project Office, which is a solution for project managers, which is again a non-CAD based system for managing the project and doing the cost calculations, etc. Integrated Engineering Office comes with integrated solution as well as standalone solutions for individual groups, and also it talks with provides an enterprise-wide solution which integrates with business systems, thereby providing you the enterprise-wide solution. So let us today we're going to focus only on PNID as a solution, which is again based on this technology and as a standalone, what benefits solution can offer for owner operators. Okay, so everyone knows PNID is a DNA of any plant. It is one of the document which is created and referred at every stage of a plant life cycle, whether it is process, instrumentation, engineering, construction, operations, and maintenance, and with different purposes. For example, a process engineer needs information about specifications, media, calculation data, etc. Piping engineer needs vendor data, equipment list, data sheets, uh, and various other reports. Procurement team needs cost information of plant objects. Operation staff needs as-built asset information, etc. So owner operator have to modify and maintain the updated PNID based on operational or as-built changes. Let's see, most of the owner operators also go through a lot of challenges. Okay, so these challenges, what are those challenges? Let us see this, because they are still using CAD-based system and maintain PNIDs as a drawing. By using non-intelligent or standard CAD or graphic PNID solution, there are limitations on the amount and quality of information that can be extracted from a system. So let us see few of the challenges which are there at various phases. Talking about basic engineering, this is where most of the process engineers actually start working on the conceptual level PNIDs. And however, there are systems which are unable to give specifications data. They are not capable of doing calculations. They have to depend on multiple systems. Also, they have to maintain various versions of PNID, as this is an iterative process or a phase. Okay, and updation or changing PNIDs is a tedious job where they have to depend on the CAD draftsman. Okay, so obviously the solution, ideal solution is object-oriented intelligent solution, which we are going to talk about, which definitely helps in doing calculations, doing engineering basic engineering during P&ID stage or during conceptual P&ID stage as well. Okay. Second is, of course, the prepaid proposal or procurement team. Okay, where this team definitely needs a lot of material specifications. They need cost estimation information to do the bid management process. So they need a lot of procurement reports. They need a lot of asset informations which they can actually plan their long lead items, buyouts, etc. So these are the challenges which is faced by procurement and pre-bid team or proposal. Talking about engineering and design, of course, the challenges are more where they want error-free PNIDs. Data consistency is a huge challenge again in this phase. They have to do a lot of design iteration. So you need a system which can handle the change management in a very effective way. You need a system which can do built-in revision control or uh, reports, or you can configure various types of reports. So these are a few of the answers to these challenges. And lastly, the operations and maintenance team. And this is the team who needs updated information at any given point in time. So maintaining and updating PNIDs is a very crucial part of it. Okay, and that's where the object-oriented solution helps in easy modification of all the utilities or plant objects, and any changes due to operation or due to maintenance should be updated in a PNID so that you have uh, as built PNIDs all the time, and you can actually look PNIDs as a good asset information source rather than just a PNID drawing. Okay, so let's see what this PNID solution is all about, object oriented PNID solution. So we're going to talk about the calculation capabilities, the spec-driven, what exactly the spec-driven or a smart PNID solution is, and how different it is from the other solutions. We are also going to talk about the revision management and change management for error-free PNIDs. So these are a few of the benefits which you are going to see in the live demonstration now. So let us see what the system is all about.
Okay, so as we have talked in the presentation that we are going to go through the quick demonstration of CADISON binary designer. So we have gone through the different phases of plant life cycles where PNID drawings can be used, such as in PNID at concept or feed or basic engineering, as well as PNID at pre-bid or proposal, then PNID at detail engineering, construction, and PNID at as built, or we can say it as a asset management information. So we'll see all in different phases of plant life cycle what type of different reports we can extract from our PNID drawings, and we'll also quickly go through some key features of CADISON PNID Designer. So our we will first talk about our PNID at concept, feed, and basic engineering. This is one of the sample process flow diagram which has a couple of processes blocks as well as which is connected to different medias. It's an process flow diagram for alkaline extractions project where there are different processes are going on, starting from mixing, testing, dissolving, and sedimentation, as well as your extraction of alkali. Now we can extract quickly the different types of reports during our concept and basic engineering. So first, on your right hand side, you will have your CADISON tree from where we can see what are the different medias or services which is used in my project. And from there, my project area, we can extract the media list either in Excel as well as in different other formats. So we can add to our document folder and the media list will be generated. So here you can see that different attributes can be populated and can be extracted to your drawings, such as media number, description, chemical formula, and the PID drawing which is associated with it. You can also have a revision document also for the media list. So whenever you are doing any update in your drawing, that will be automatically updated to your reports also. As we have gone through the process flow diagram, the same process flow diagram will be used to create your PNID drawings. So we have document folders for all the PNID drawings, which has the medias or process, which we have already created in our process flow diagram. So we can also extract the pipeline list for our concept and basic engineering life cycle, where we can extract the reports based upon our pipeline list. So you can see the pipeline number reports with all the different pipelines, process media, pipe material, or insulation thickness is even with the PID drawing number has been added to your reports. As we have done for the pipeline list, similarly we have lots of valves in our PID drawings. So we can extract the valve list also based upon the different types of valves available in my PID drawing. So again, we can go to our PID drawing, go to report folder, and can quickly extract the reports. There are predefined templates for all the reports are available. This is some of the different types of reports which you can extract it using CADISON PNID. So you can see the for valve data summary we have media information, valve description with the tag number, type of valve with the end conditions, and other specification related values with the PNID number is added to your reports. Other type of report you can extract is your instrument lists. So you can go through the different types of instruments, and its information can be available using object inspector dialog box. So there are different types of instruments can be created, whether it's a measuring point, or if there is an instrument for a safety valve. So you can extract the instrument list reports from PNID drawings. So let's say select the instrument list report template, and your instrument list reports will be generated. So this is something like we can quickly and easily extract the reports based upon the objects available in your PNID drawings. These reports are fully configurable. You can add or remove any properties from the report template which is required as per your project requirements. So you can see tag numbers, drawing numbers, different information related to your instruments is available in your report format. All the instrument information with the supplier, model number, types is available there. Now there are couple of special component or special items will be there in your PNID, such as your coupling compensator, or maybe a strainer, pulsation damper. So these are all special items. You can generate the reports for your special items also, which will have different templates and different attributes will be available. So this is a report for special piping components, item names, type of component with a tag number, size, all those values will be populated. Even the quantity also can be generated. Lastly, we have a couple of equipments available in PNID, such as sedimentation tank or filter press. So we have reports for vessel list also, because in basic or concept engineering we generate the vessel list also. This is a predefined equipment list available with all the tag numbers, description, and specification details with the drawing number is available. Now we have seen the PNID at a concept or basic engineering phase. Let us go through the PNIDs and how the different types of reports can be generated at pre-bid and proposal level. Once our concept engineering is done, during my pre-bid, we can have couple of PNIDs. Right now, you can see there are 4 or 5 number of PNIDs available on your screens. And during my pre-bid phase, I want to generate the list of pre-PNIDs, list of PNIDs for our pre-bid or proposal engineering. So we can generate based upon our document folder level. We can generate the reports for list of PNIDs, and you can have the reports in a Word format as well as in Excel sheets also. Here you can see the description of your PNID drawing, drawing number, sheet number. If it is revision, you can get the revision number as well as the creation date. So this type of reports you can quickly and easily create it at any level, whether you want it at the drawing level, at the document group level, as well as at the project level also. We have seen during the pre-bid phase the list of PNIDs. Now let us quickly see the equipment list for all the PNIDs at the document level, document folder level. We can create the reports. So we'll go to vessel list Excel report form of template, and we can say that this is a pre-equipment list, which is for pre-bid proposal level. And based upon the number of PNIDs, it will generate the equipment list, which consists of all the tag numbers for the equipments, description, the different equipment specifications, capacity or volume, design conditions also. Now, one of the important report format during our pre-bid is data sheets for the equipments or for the pump data sheet. So for example, we have a sedimentation tank with a tag number B3205, and it has all the relevant information is there in your PNID, and we want to generate quickly a data sheet for this equipment. So again, on my right hand side we have CADISON tree, where we can filter out to our equipments. So I will just filter out to my sedimentation tank, and will generate the reports by selecting the sedimentation tank there. So it will add the file name for DS datasheet for B3205, and based on that our data sheets is created. So you can see it is showing all the relevant details of your project. First of all, that is the location, project number, what service it is flowing, the item code, the data related to fluid state, capacity and specification details of equipments, and material of constructions also. You can also have, based upon the data sheet template, you can have a nozzle schedule where all the information related to nozzles can be also seen in your report of data sheet. So this is a simple example that whatever data or information there in your binary drawing can be automatically extracted to your report formats based upon your project requirements. Another important document during our pre-bid and proposal engineering is your cost estimation. So let us quickly take an example that you have number of valves in your PNID drawings, different types of valves, and we have to quickly do the valve cost estimation. So if we select a valve, we have an attribute known as list price. So this list price can be either taken it from a vendor catalog, or it can be added manually, or we can import the Excel sheet format for to add those list pricing. Once the list price is added to an object, we can extract the reports for the cost estimation of the walls. So if I go to my project level and at my document folder, select the drawing and go to the reports. We have a report template for proposal wall cost report, and will generate the report in Excel sheet format. So once the wall cost estimation is generated, it will not only show the costing but all the relevant information for the walls, such as area description, area codes, item tag number, and cost related to that. Even the quantity can is available to you. So this is a sample report template for cost estimation, and this is fully configurable based upon your project requirements. You can also see the total cost of the uh, once the wall cost estimation is done, your total cost value will be added to your sheet. Next, we will quickly go through the PNID at detail engineering and construction stage. Now, in detail engineering, we different types of reports are once again generated, such as your final list of PNIDs at project level. So we can go to the project level in your CADISON tree, and we have see a lot of PNIDs documents are available. You have PFD drawings, media distribution drawings, and different PNID based upon process um, in your projects. So you can go to your project level and select the template for list of documents, and can generate the reports for final list of PNIDs. So this is a word template for the reports. You can also have the Excel sheet template where you can see the description of your PNID drawings, drawing number, and the creator as well as the creation dates. This template can be configured and can be you can create your own custom properties can be added there. Once the list of PNID has been finalized, you can create based upon different PNIDs. You can create final list of pipeline list. So again, I can go to my project level and can generate the reports for pipeline list. So this is the final list of pipelines, which has all the relevant information for the pipelines, media code, installation thickness, what PNID drawing consists of the pipelines. Next, you have final equipment list. So based upon the different PNIDs in your project, before that, we will see through the final special component list available there based upon different PNIDs. So you can see for the couplings, all the items are available. Pulsation, damper, strainers, side class, all the special component list with its tag number, material, and size is available. Now we will quickly discuss about the last stage of PNID, that is as built or asset information management. During the plant design, we every projects had different types of tagging systems, such as you can see uh, we have different tagging philosophy in this PNID for pipelines. We have tagging system different for walls as well as equipments also. So By default, there are two different types of tagging systems available in CADISON. One is standard and another is KKS. Tagging systems can be changed based upon the project requirements, and users can add their own tagging requirements as per the project requirements. So how to configure the tagging philosophy for a pipeline or for a different types of objects available in your PNID. So let us quickly go through one example. If I edit a pipeline in my CADISON tree, we have a property which is known as device tag with plant ID. This has a formula which shows that pipeline tag number has been created from two attributes. One is the plant number and the code. Using these two properties, we can create our pipeline tagging. This is one example. In the same way, the tagging for other objects such as equipments, valves, or instruments can be created and can be formalized based upon different attributes. As we are talking about asset information and as built, so these PNIDs can be used throughout your plant life cycle, and it can be used as the maintenance documents. For example, if you have different n number of valves available, so you can quickly select it the valves in a tree and can zoom and highlight in your PNID drawings. So if you have a complex PNID drawing, objects from a tree can be selected and can be quickly highlighted and zoomed to the area in your drawing. Such as for instruments, you can select it from your CADISON tree and can zoom and highlight to your graphical area. Next, I would like to talk about when we are talking about asset information and its management, we have a bidirectional links of CADISON PNID with ERP interface where all the PID with its standard items can be stored in the CADISON database, and from where CADISON database the properties or attributes can be linked to the ERP projects such as your material, desired delivery date, suppliers, etc. And in ERP we can add more information related to projects such as pricing, order confirmation, etc., which can be bring back to our CADISON database as well as your PID drawings. So this interface gives a advantage where all the data from the PID can be bring back to our ERP systems so that can be used for procurement teams, and then procurement teams can give their data or information back to the CADISON database, which can be used bring back to your PID drawings, and you can generate the reports based upon the project requirements. Now, as we have gone through the different report types of reports which we can extract it using CADISON PID Designer, starting from concept, pre-bid, detail engineering, as well as built and asset information management. Let us quickly go through key features of CADISON PID so that how quickly and easily you can create your smart PIDs. So first I will talk about media, pipe specifications and different types of calculations. So in your PNID, you can create multiple media, that is services, which will be flowing through your pipelines, which is visible from your CADISON tree. You can see n number of media is available. Each media you can associate with its piping specifications, and the piping specification will be added to your pipelines. So pipelines will have all the relevant information which is coming from your piping specification, such as your size, your material, and other relevant information. At the pipeline level, you can do your sizing calculation. So in order to size the pipes for optimal economic requirements, CADISON PID provides a new feature to conduct the pipe sizing calculation, which accurately estimates the pipe diameter, pipe thickness, and the pressure drop in the pipes. The pipe calculation feature utilizes the resistance factor method to calculate the parameters. So you can provide the inputs such as inside diameter and other pipe relevant inputs, and you can calculate the outputs in terms of pipe diameter, pressure drop, and the minimum required thickness for the pipe. Based upon the inputs, you can calculate the sizing calculation for the pipelines. Now, as we have done for the piping, same thing we can do it for the pump sizing also. So CADISON also provides a feature for pump sizing, which facilitates appropriate selection of the pump. Pump sizing calculation performs hydraulic calculation for centrifugal pumps and estimates differential head, hydraulic power, motor power, as well as net positive suction head available. So you can provide all the pump information such as your density, vapor pressure, pump efficiency, and you can provide inputs for suction side as well as your discharge or pressure sides, and based upon that your output will be available. That is your total differential pressure, pump power, net positive suction head. Next is the construction set, which we call it as a assembly manager. So construction set is something like you are creating an assembly of objects which is connected to your pipelines. So we'll take an example here. We have a small valve assembly which is connected to a pipelines and inline objects such as coupling with hose, and we want to place it at the top of your pipeline. So using construction set tool, we can quickly select the graphical area which you want to place it as assembly, and we can provide for which standard we are taking this assembly. We can provide the insertion points which will be used to place this construction set, and we can give some naming convention to this construction set or assemblies. Let's say I'm giving as a valve assembly. Zoom option will provide you a graphical area which will be seen in your library. So once the construction set is created, that will go to your object manager, which is a CADISON library, and you can have all your different types of assembly will be available in your object manager. Now let's quickly place it on the above pipeline. So from our CADISON menu, we'll select the object manager, which is an assembly manager here, and we'll go to our construction set option. We'll quickly drag and drop our assembly. Now the beauty of the software is this is not an overall assembly. These objects are placed individually with the updated tag numbers. So you can see the tag numbers has been updated, and these individual object reports can also be generated. So this construction set is a assembly which is not only used in a current project, but it is saved in your library and can be used for further in future in different projects, as well as in the current project with different drawings also. Next we will talk about change and revision management. So during our PNID creation or during our plant life cycle, we have different types of changes, occurs based upon the graphical changes as well as value or attribute changes. So we are taking an example that we have a couple of valves, multiple valves are available, different types of valves, and how quickly and easily we can edit some properties for valves. So if you see, there is a ball valve whose couple of values are empty, such as if you go to our manufacturer value and type value, both are empty. So how quickly and easily we can update the mass updates in our PID drawings. So we can quickly select the overall drawing using edit object command, and we will get automatically a spreadsheet which will have all the entities selected in our drawing. We can filter out to our valves using object class name, and again we can sub filter it based upon the valve description. So here I am selecting ball valve. Excuse me. Now I can see there are 7 ball valves available with its manufacturer and type value empty. Now the question is how we can quickly add those values to the manufacturer property and type property. So we have an option that we can select the property name using fill and number option. We can give property value one at a time, and automatically the values will be updated for all the valves. Same way we can do it for the type property. So you can see the values has been updated. In this way, if you have suppose 50 or 100 valves, you can select all the valves, you can get this spreadsheet, and using fill and number option, all the values will be updated. To verify it, we can select the one line of the valve and we can zoom and highlight to your drawing, where we can check whether the valve property has been updated or not. And you can see once we edit the valve, the manufacturer value and type value has been updated. Now after the changes has been done, these changes will be automatically updated to your reports also. So you don't have to create a new reports. If you go to your reports folder using CADISON tree, all documents, you can go to your reports folder and you no need to create the report. You can just update the reports. It will automatically create a revision of your reports where you can provide the revision text such as your manufacturer value updated, and you can have a revision of your reports also. So once the valve data summary is extracted, you can see for the ball valves, the manufacturer value, GF and type 546 is updated in your reports. And also a revision A has been generated for your reports. So this shows the revision management also. Once the changes has been done in your drawing, your revision of the reports will be generated automatically. Now comes the revision of your drawing. Once the changes has been done in your drawing, we have an option to create a revision table where you can have a new revision for your drawings. You can provide some description to this drawing, and once you click OK, your revision will be added to your revision table near the title block. So you can see the initial revision has been added. So how to verify my drawing is revised or not? If I go to my documents, all documents in CADISON tree, if I filter out based upon all documents and revisions, and once again I will go to my PID drawing in my CADISON tree, we will have a revision of your drawing with the description also. That is the initial revision, who has done this revision as well as the date. So this is a small example that how the changes takes place in a PID drawing and how quickly and easily you can update the changes in your PIDs, and that will be updated to your reports as well as your revision of your drawings also. Now once the drawing is created, you have to annotate it, or you can designate it based upon the properties for your objects, and you can generate an legend sheets also. Let us go quickly through the object designation and legend sheet command. So object designation command is used to provide annotations to the objects placed in the PNID drawings. These designations or annotations can be configured and can be saved for the further usage. So you can see right now equipments have some informations, and we can create some typical text masks. So we have predefined text masks available. Even we can create our own text mask templates and can add to our library. So here we can select, using the graphical option, we can select the object and the text marks will be created based upon the template. So you can see for the segmentation tag, tag number and other technical data, specification data is available. In the same way, we are going to do it for the steerer also. From my library, we can quickly select the template, and using graphical option, the text marks will be created. Here are the quick some examples of the text marks which is already created, and these types of text marks you can add it to your PNID drawings. This is the default template, but you can customize the text mask template as per your project requirement. Next is, we have different types of object designations are available, and you can configure it and save it for the future uses. So using the common object designation command, you can select the object to provide the annotations and can configure it based upon the properties required. For example, for a pipeline, I am taking my tag number as first as a sub plant, that is plant code. Then I'm taking the media number, and we can provide the free text also. Then the piping specification, and let's say the last one as the counting number, that is the pipeline number. So once my formula is created for my annotation, I can click OK, and I can provide the text size, whether we want to place the orientation of the text horizontal, etc. And we can apply it to our pipelines. So you can see, based upon the formula used, my plant code, media specifications, and the line number is counting number is added to my pipeline in my PNID drawing. In the same way, we can quickly annotate to the other pipelines also, and based upon that my value is updated. Now the beauty is that if any changes done in your PNID drawing, these annotations will be automatically updated. You can add as many attributes from your object designation to different objects, such as you can annotate it for your equipments or for inline fittings such as valves also. Now, once your pin ID is done, we can quickly generate your legend sheets based upon your pin ID drawing. We have a default legend sheet template is available, and based upon the drawings or the objects placed in your drawings, your legend sheets will be created, and all the object symbols with its descriptions can be added it as a legend. So you can see all the components which is used or symbols used in your PNID drawings. It will create a block which will contain the symbols with its descriptions also. Next is index sheets. So index sheet contains the list of the drawings present in a document folder or a document group. So we can quickly create a new drawing, and we can provide a name as index sheet. We can open it, and we can place a title block and border which will contain the list of PNIDs used in during my project. This is an empty title block and border, and from my library I will select the template for the index sheet and will select the list option, where I can browse to my document folder or document group where all of my PNIDs is available for the project. So once I select the document folder for the PNIDs and will click OK, it will automatically extract the list of the PNIDs as an index sheet in my drawing. So you can see the title number, serial number, drawing number, if revision has been done, and remarks can be played. Now other thing is that if any drawing or PNID drawing has been added to the document folder, this index sheet will be automatically updated. For example, I am creating a drawing and giving the name as test PNID. You can see the index sheet is updated automatically with the title and the serial number. If we edit anything to the sheet number, let us say 007, and the description I have changed it to the test PNID, and that will be automatically reflected to the index sheet. So this gives you an advantage that you don't have to, once your index sheet is created, you don't have to create it again, and it will be automatically updated based upon the new drawings added to your document folder. Lastly, I would like to talk about the logic analyzer. Logic analyzer is a quality checking tool which helps user to check the logical errors in your project. It provides a wide range of check routines. So this logic analyzer is available at the drawing level as well as your project level also. So we have this logic analyzer at both the levels. Let us take an example, and we execute it at the drawing level, and we want to check the duplicate tag numbers for the equipments. So these are the predefined checklist available, or you can say logical error checklist is available. You can create your own rules and add it to your logic analyzer table. Now here we are going to check test an example of uniqueness of equipment codes, or you can say if there are any duplicate tag numbers for the equipments is available, it will automatically check it. So we will select it for uniqueness of equipment codes and click OK. Here we see that there is no checklist is available because we don't have any duplicate for the tag numbers. Now let us quickly test it for a couple of equipments. We have two equipments. One is an autoclave and another one is sedimentation tank. So what we will do is here we will change the tag number for autoclave with the same tag number which is there for sedimentation tank, and we'll save our drawing, and we will quickly run the logic analyzer to test for uniqueness of equipment tag numbers or duplication of tag numbers. So we select uniqueness of equipment codes, and we'll see that the description that the device tag of this device is not unique, and it is showing the same tag numbers for both the equipments. Now what we can do is we can select one of the vessel and edit the vessel. Here only we can change the tag numbers, which was firstly it has been defined, and we can close this dialog box. You can see in the drawing that change has been updated. Now again, if you quickly run the logic analyzer, and that logical error has been removed. So in this way, you can check your PID drawings based upon any error such as uniqueness of pipeline tag numbers, valve tag numbers, or equipment tag numbers, or if there is any mismatch for your pipeline sizings, or if you can also create your own rules based upon your project requirements and add it so that you can perform your quality checking once your PID is done. So this was all related to the different key features of CADISON PID. There are different types of applications which can be used from intelligent and smart PIDs. First is training. So when plant is in operation and existing users or process engineers knows about different plant areas, media, pipelines, and other specifications because they are working on it. Now, if any new process engineers joins, so in that case, CADISON PNID can be used to get the training to the new team of the process engineers, and they can get familiar with the existing plant operating conditions in terms of sub-plant areas, what media is flowing through different pipelines, and new users can actually zoom and highlight with the objects so that they can get familiar with the existing plant which is in operation. Second application is as built. So typically there are a lot of changes happen in plant life cycle or during plant operation. Now challenge is how this change management should go smoothly, and different disciplines can have the updated data. So here PNIDs can be used as built document or can be used as maintenance document from which you can get the updated data in form of different reports. Third application is legacy conversion. So the migration or conversion should help organization automatically migrate application to modern and open technology and database management systems. So here CADISON PIN can be used as maintaining all your operational assets such as your old plant data, drawings, or different specification details can be make them into an intelligent format. And the last is HAZOP. So an important element of any system for the prevention of major accident is conducting a hazard, or you can say operability study at the detailed design stage of the plant in general and the operating and safety control systems in particular. The hazard process is used to identify the potential hazards and operational problems in terms of plant design and human error. So in this case, CADISON PIN ID can give you the list of medias, pipelines, and other drawing details which are relevant values in terms of reports and which will help in our HAZOP processes. That's all for today's webinar. Thank you for attending this. If you have any queries or concerns, please put your queries on the comment sections, or you can contact us, or you can get the details on below email addresses. Thank you.